like it means nothing.
All right. I'm literally going to show you slides from 20 years ago. I thought a bit about how to pull this through. My team kind of suggested I could speak on one side to tell you what I told you 20 years ago, and then I could go here to tell you what I'm going to tell you now, but nah, that won't work. So let's see where we end up. This was an internal training set I put together back at F-Secure, and when I did a dry run with my team, one of the comments was that how many companies had an R&D security advisor back in 2004? I had to work on the slides though because they were in 4:3 format, and the format of the file was a PPT, but I managed to somehow convert it. And also actually I got permission from the copyright holders to actually show this. So, you know, when you nick something for your previous employers, ask for permission before you present them. About me, when I did this presentation, I had actually already been working on security in one way or another for 10 years. So on this small CV, the summer trainee in the Nokia Research Center is kind of relevant for the reason that Tatu was building SSH, and Nokia actually had a firewall, and I tried to somehow get through the firewall to use the internet. You know, web browsers and stuff. There was no TikTok or anything, so it was actually for work. So I had to compile SSH. And compiling SSH was a bit hard because Tatu hadn't compiled it on the hardware we were using. So I got pretty good at compiling SSH on various hardware. I ended up getting hired in '96 to a small company that became F-Secure. We were roughly 30 people back then. And the job was simple. I was writing on Usenet about how to compile SSH. And then they were like, well, what if you started working for us? We would pay you for it, but you just keep writing on the internet on how to compile SSH. And as I was studying, that was kind of perfect. I eventually managed to graduate. My master's thesis took a year, but actually just 2.5 days to write. It was the first draft, and it was good enough, so I don't know. A moment of glory and a lifetime of disappointment, or which way it goes. But then I worked for F-Secure for quite a while, and in 2004, I thought I knew enough to actually train people about it. So this was the agenda, thinking about security. And I think the topic here today is the same, like try to reflect. For some of you, 2004 might be a long time ago. Yeah, it probably actually is. And then I tried to put together for a software engineering crew the topic on 10 things to remember when you design secure software. So this is now about defense. Not the cool attacking stuff, but actually how to build something that lasts. And again, I'm a bit of a kind of caught in the slide deck I have because it is the original. So how to respond to a security hole here means you are a software engineering organization. What do you do? But back then there was a big discussion about security vulnerabilities. Like, should you disclose? Should you partially disclose? Should you just be secretive about it? And we've kind of now come full circle because most of you are using some SaaS software. And the SaaS vendors perhaps just silently update their services, and they won't actually tell you that, hey, we had this critical remote code execution vulnerability, but hey, trust us, nothing to see here. So in 20 years, I think we are kind of back to the ostrich defense. Let's pretend that the SaaS software is safe and everything is good. But think, when I go through things here, think about what you could do and what you could take away from this, because it's an old deck, and I'll try to translate it perhaps a bit to today in the end. But it's not really about me teaching here, as it wasn't 20 years ago when I ran this internal training. And again, if you find that you don't know and understand, remember to ask. I can also be found after this somewhere. Oh, I have Mikko in the audience. This is Mikko's idea, actually, by the way, that I'm here. Because I kind of found this deck, and I figured out I could run this again. And Mikko was, yeah, please do. But before we jump into it, I did during my studies dabble in cryptography. And I still remember Kajsa Nyberg's lecture where she was standing there in front of a fairly complex mathematical kind of computation, and she said, and from here you see that. And I was like, nope, I don't. And that was when I realized that cryptography isn't for me. But it's a very common theme still today that we have this problem, security, so let's add some encryption. But unfortunately, it doesn't work that way. If you had one problem before, now you have two, because now you have a key management problem and you have your original problem. So think carefully about adding encryption to anything. Okay, but those 10 strategies. First one is learn from history, which I suppose nowadays means learn from me, but I don't know. Then protect the weakest link. Implement separation of duties. And again, think software engineering here. Some of these are more general as well, but anyway. Enforce least privilege. And hey, by the way, these are a bit like security requirements. They're really easy to say, but not always so easy to implement. And then practice defense in depth. I'll go into this a bit more. It's still one of my favorites. Never trust input. And when I say never trust input, I say never trust input. Fail safely and fail securely. I'll go through a bit what's the difference between the two, actually, and why I actually would like to have both in your software. And do ship stuff secure by default. One of these days, I'll get a piece of software that is secure by default. Haven't seen one yet, but hey, perhaps one day. Security is also a process. It's not something you do and then you're done, and then you ship it, and then you go back to doing something else. Keep it simple and straightforward. No, keep it simple, stupid. That's the way it goes. And the final one is to fuck up is human. And there are so many ways we can fuck things up. So, learning from history. There's lots of material that has been written. And when I made this presentation in 2004, I fell back to material that I'll reference later in this presentation that I had read. So many of the principles were already worked out in the 80s when the US military was thinking about how to build defendable systems against nation-state attackers. So if you don't spend the time to learn from others' mistakes, it's not only stupid, it's actually incompetent by now. And yeah, OWASP is a good place to start. Here again, I got a good comment from my team that, yeah, but nowadays there are many different top 10s for different industries. I'm like, yeah, this depends on what the industry you're in. But the same topics keep reappearing. And the 2025 version is about to come out pretty soon now, I hear. It has been about to come out for months. My guess is they're going to shuffle the order of some of these. So you can start off with this list, and when you know them, you can go on to something else. Then about protecting the weakest link. Now, there's always going to be countless different things you can do about improving security in your software, but it's not really useful to work on the most obvious ones. You have to figure out in your architecture and what you're doing, what is the thing where you get most bang for buck for your thing? And it's not always the obvious first one that you see. This is something I had a problem with when I started out in the career, that, hey, I knew about a few kinds of vulnerabilities, so I always looked for them, and then we tried to fix those. But that's not necessarily the right thing to change. So you actually need to spend the time, go through your architecture, think about the exposures you have. And unfortunately, risk isn't static either. There is more to be said about risk management. If some of you are into, ISO 27001 and others, there are interesting 5x5 diagrams where you can score risks. Fun fact though, I also had a training where I was participant about 20 years ago, where it was proven that mathematically it doesn't make any sense to combine risk that way. And actually, if you want to talk about risks, you should do it in another way. I'll come back to this a bit later as well. Separation of duties. This is really about avoiding spaghetti design. But from a security perspective, there's nowadays many better ways of doing it as well. But it's about separating behavior and enforcing behavior. In your designs, make sure you understand how you implement certain security functions and keep them encapsulated as they run. There is also a minor detail here which providing enough aspects or operations to allow fine control. That's really the authorization model. So if you looked at this talk about Enter ID today, you had the authorization models, the problem of token stealing. But even just designing the authorization model, that what can the users actually do, what rights can you give out, is sometimes incredibly hard to get right. Here's an example, and again, I'm a bit caught by the slides I made 20 years ago, so we have to go with the ones we had. Internet Explorer was actually the browser back then. And Internet Explorer was convenient that you could run object linking and embedding software. They called it ActiveX at the time, which essentially meant that you could download and run an arbitrary Windows executable on your machine, and it was supposed to be safe. And this was a time when, like most people were running administrator, people were still running Windows 95. You didn't have any protection for any binaries. But for some reason, it felt like a good idea to, download a signed binary and run it. It's distinctly something that I need to apologize for this presentation. Like, I picked at the IE team back then. Almost any example I picked was Internet Explorer, but it was the biggest hole on the internet, and they sure had it coming. So. They kind of earned it. But hey, then we come to something like this. And allegedly, according to the internet, I read it on the internet, so it's true, the Russians used this hole against the Ukrainians this year, where when you embed a 7-zip archive in a 7-zip archive, the inner archive that you extract, those files are not marked as, mark of the web, so they don't have the integrity protection, so if you execute them, they will actually execute on the system. So this was actually used by Russians. So the IE lessons of downloading stuff from the web and executing it, perhaps we haven't come that far. Hard to say. Enforcing least privilege, again, it's something that's easy to say. But what is least privilege? What is the thing that you actually need to run? Sometimes your unit of code, whatever box you are designing the security for, actually is doing many different things. And then you try to figure out what that privilege is. This is something I found it's incredibly hard to retrofit into a solution. So if you have a piece of code that's running as domain admin in a Windows environment, how do you know what privileges it actually needs to run properly? Unless it's documented and tested. So when you build a model, make sure that you test that it runs with those privileges, and it cannot do the things it's not supposed to be able to do. So both positive and negative testing of the privilege model is really important. And if you run into the situation, which, by the way, if you are implementing anything related to software development, you will eventually run into it, which is that you will need to do one more thing, right? And then you just add more permissions to your piece of code. And after a while, you pretty much have every permission on the system that you need in the first place. So as you run into a situation where you need more privileges, you need to refactor your code. Well, the privileges that Internet Explorer had, again, picking on them, it had the privileges to run arbitrary code on your PC, and it felt like a good idea at the time. Defense in depth. And here, I'd say many people think about defenses as something static. But you should actually be thinking about time-based security. The thing that really matters is all these defenses, everything you build is there to slow down the attacker, to make it harder, to make it noisier. We should learn something from the safe industry. Like if you buy a really good safe, they will tell you how many minutes it will withstand an acetylene torch. But the rating is minutes, like a 5-minute safe. 10 minutes safe, it's not 100% secure, right? It's 5 minutes secure. So when you engineer something, you build something really strong, but you don't put in any detection capabilities, any alerting capabilities, any response capabilities. It doesn't really matter that much. Eventually it will break. So sometimes it's enough to just build the detection and response capabilities instead. Think about it. The never trust input. I don't know. I had the opportunity to work with a team back at F-Secure that worked on a content platform that some of you might have used, some of you not. It was called United. And it was a bit like Google Photos, a bit like those, but it was a bit ahead of its time. But it had this kind of challenge. That idea is people can upload arbitrary files, photos, videos, and then the product owner was a bit like, yeah, but we would like thumbnails. So what do you do if you get arbitrary media files and you want to transcode them? Well, back then you took FFmpeg. We checked out FFmpeg. Like it had 42 or something like that code execution vulnerabilities. And then we had this kind of challenge that, yeah, but we kind of need to run FFmpeg because like the open source community has been spending a lot of time on figuring out how to transcode various kind of formats. But it's almost impossible to do in a safe way. That was a really cool bunch of people to work with. So we figured out how to run FFmpeg on content that we were pretty certain is malicious. And if we got a malicious file in, the worst thing that could happen is that we output a malicious file. So I don't think a lot of bad things have happened. Well, potentially, perhaps somebody could have run a crypto miner then, but this was so long time ago that crypto mining wasn't really a thing. So I also had discussions with developers over this one at some point. It got a bit challenging because they said, we are running a backend component. Like, why do we need to check the input? So I was, okay, so who is going to check it for you then? Because any component earlier in the chain, the web front end, web firewalls, whatever you put in front, they're all just going to be pass it through. So actually your parser, wherever your parser is, even if you're running the parser in the kernel, and hey, no antivirus product ever ran a parser in the kernel. If you run a parser in the kernel, you're going to be the first sucker or bastard or whatever you want to call it, who is going to be looking at that data. So you had better treat it as untrustworthy. Yeah, that may be unintuitive until you realize that nobody else is actually going to be looking at the data. You are going to be the first developer that's interested in it, regardless of where your code runs. Back then, we also talked about this avoiding dangerous functions. Everybody was coding in C, and the C runtime library back then, most of the standard functions are absolutely hazardous to code with. I wouldn't let developers touch C anymore, but back then that was the thing to do. About ActiveX controls, remember they're called object linking and embedding. I looked at something from January. Actually, I looked at it very, very carefully before I'd open my email, because Outlook had this very nice feature that if you have an automatic preview in Outlook, it will execute code on your machine. I don't know. Are we learning anything? Kind of interesting. But it's essentially the same problem all over again. The attacker can send you the code and will happily execute it. Failing safely, failing securely. The example of an electric lock I used is kind of interesting. So in a building where you have electric locks, and we have them here as well, a fail secure means that if the system fails, you can't get out or in. But if it fails safely, you can actually get out in case of the fire that caused the system to fail in the first place. But when we do software engineering, we actually get to choose this a bit more wisely. We can pick a bit of both. So make sure that when something odd happens, your system reverts back to a safe mode of operation. It's really easy to say again. Like most of these prescriptions, I'm just a wise ass here telling you what you should be doing, but actually trying to implement this is going to be really hard. But this is relevant to testing, because I've so many times seen unit tests being written with the attitude of, oh, hey, let's try to catch random failures. But then we have people that get really good at fuzz testing. And fuzz testing isn't random failures anymore. Fuzz testing is actually when you drive the system very, very purposefully towards a certain state. And then you actually try to kind of make it fail in unpredictable ways. So your job as the developer is that under fuzzing, when something strange happens, and eventually you will end up in that code path, make sure that your code behaves in a secure and safe way and exits in a way that the system keeps working. Again, really easy to say. Secure by default, I don't think this resonates the same way now as 20 years ago. Because 20 years ago, nothing shipped hardened. Like, there was a small software industry even just developing hardening tools for the very, very, very insecure default configurations of all operating systems. Nowadays, I think we are in a much better state than before. But there are still issues for the average developer about how do you think about what is the default? Like, who makes the determination? And then you pop something up to the user and said, like, hey, would you like to do this or that? If you don't know what the default secure configuration of your software should be, why do you ask the user? I think that's a pretty bad choice. So this kind of implies that the defaults that comes out of the box shouldn't be asking stupid things. Ideally, you don't ask anything at all. And then the process element, I think this has become clear going through this deck and also going through my reflection on it, that the software will have a life cycle that extends far beyond your initial design. And this means that when you think about keeping your software secure, you should build it into your development process from the outset. It's kind of a easy thing to say, but nowadays we have many guidances. There's BSIM, OpenSAM. There are many frameworks that you can use to pick those elements in your software development process that you make sure that your software passes through these gates every time. You do the necessary checks. There's one thing on this slide, though. I did used to say that it's an unfair game. You need to find all the weak spots, and the attacker only needs to find one. I've thought about this, and I think nowadays it's really the other way around. If you build something that's well hardened with good defaults, you have alerting and detection capabilities in place, you can actually mine the environment in a way that an attacker only needs to make one mistake, and actually that will trigger your response. Remember the time-based security here again. You should think about security as that time-based thing where your software is just element in the actual fight against the attackers. Patching is hard. I thought about how to say it, but this is actually the whole and important thing. In any non-trivial environment, you will never reach a state where all systems are patched against all vulnerabilities. Like for endpoints, for instance. Okay, we have automatic patches of laptops. Windows updates go in, macOS updates go in. Oh, users went on vacation or honeymoon and didn't boot their machine for 2 weeks. So you will always be in a state of patching is incomplete. So design your defenses and systems against this assumption that stuff will be out of date. A team member pointed out, though, that there were only 42 advisories on Internet Explorer in 2 years. I forget how many and what the counts for Microsoft's advisories nowadays are, but it tends to be like in the 40s or 50s for the Microsoft stacks or the software they release on a monthly basis by now. So not only has the software gotten incredibly more complex, the number of patches you need to deploy is much bigger, but they also come at a much higher pace. You are not immune, but this one is actually now targeted again to the developers. This was an internal training. And I still remember the smell of the meeting room from this one. It was LHA. It's a very obscure file format, and if you have an archiving product, an antivirus product, you have to support almost any archive format since the creation of computers, roughly. LHA is nice because it's kind of semi-open source, made by an obscure Japanese coder that disappeared or something like this. I forget the details. It's 20 years ago. Apologies. But that particular integration was in a library that, of course, affected all products we had. And we had different versions of that one. So figuring out beforehand, how do you manage dependencies in your own code so that when something is found, you can actually deploy it across your entire infrastructure is non-trivial. Like if you are in a small software company, you're making one product, and you get one library update. You can manage it, I'm sure. But once you have a suite of products, some of them may be something you ship, something you host, something somebody else hosts, and then you try to figure out, okay, so how do we manage the dependencies of all of this? You probably don't want to sit in that meeting room. It was one of those meeting rooms, where it's split in two, but then you can open it in the middle. So we actually managed to fit more people into the room to sit there. And fortunately, we were able to coordinate this. And I think in hindsight, it was one of the best managed vulnerabilities we had back then. It also was the problem, of course, that we were using the LHA code that everybody else was using because it was available just in source code format like open source. Actually, it was public domain. So we had this slight problem of coordinating with others as well. You have to plan for this beforehand. Or then you get to sit in a sweaty meeting room with lots of people. It's not the stink of fear that you get in security incident, but it's definitely a smell of high stress, right? And I don't know if you've ever been in such a situation. It's also contagious. So humans are biological beings. So once that sense of stress and smell, it's really hard to moderate. Keeping it simple, stupid. This becomes easier in more modern software architectures where you don't just ship one huge binary. But I would say that from your security model, and I could take an analogy here again from a development team. I worked with a very junior development team. I actually flew pretty far away and had a training about how to do architectural threat modeling. And the thing that's really difficult with one of the teams. So I was looking at their picture of the architecture. I couldn't really get it, but I had this kind of workshop space where there were many different teams working, so I couldn't focus just on them. So it took me a while to understand that they had drawn the software layout in the repository. And then I asked them, okay, but how does it run? And only then did they actually understand that they asked about the runtime view of the software. Like the developers didn't really think runtime view. And then when we looked at their security architecture, there was just one box left because everything ran in one process. So you really need to figure out how to simplify your security model so that you can understand it. Preferably, you have a few critical security functions that do this. The best example of this I can think about is really actually file system access control. And I think almost everybody here has battled file system access control at some point. But that is enforced by the file system itself. And unless you get a raw device I/O to the actual underlying hardware, you're not going to bypass the file system access control. So think about how you can do that same in your architecture. Then the bonus one, which is that we are all human, and the mistakes that will happen will affect your security. The first one I already talked about, or the second on the list here, that users, if you ask the user a question, some of the time it will definitely be a stupid question. The example here is a bit of an old mobile phone. I don't know if you recognize it. This particular malware had an interesting feature. It actually spread via Bluetooth. So it was a Bluetooth worm. You would think, well, why would anybody accept a Bluetooth worm? Well, because it will keep asking until you accept it. So your phone will have this install carrier, yes, no. And if you say no, it will ask again, and it will keep asking. Who thought it was a good idea? That's a different discussion. But this is the kind of things we end up in when we don't understand the underlying actual dynamic user model of the user. So attackers quite often can utilize these kind of stupid questions and essentially tell the user, yeah, click yes, things will work. How many here has never seen a pop-up like, do you want to run this? Yes, no. Yeah, nobody. So, And I'm not going to ask how many you have clicked on, yes, I'll run this, because that's what you're out to do, right? Okay? So then you expand this to administrators. Now, administrators are a bit like ordinary users in that they also make mistakes, but their mistakes cost much more, and they're usually underfunded and have too much to do. And if you're stressed out, it gets much worse. So don't ask admins stupid questions either. And then when you design something, you can also make the assumption that the underlying system, the thing that your software runs on, is correct. I'm not going to dive too much into that one, but it causes a lot of interesting side effects. So you can definitely assume yourself into trouble without any bigger problem. This is the original material slide I had. I looked it through. I thought, should I make a new one? I shouldn't. These are good references still today, particularly one. How many of you have read Ken Thompson's Reflection on Trusting Trust? Hands up. Okay. I think it was in '84 Ken Thompson got the Turing Prize, which back then was kind of a Nobel Prize in computing, but computing was very small. And he described this concept of how to make an untrusted login. So the thing is, in Unix you have the login process, and the login process will ask you for a username and password. And for an attacker it would be really nice if you could put a backdoor username and password there. But the problem is that if you put that into the source code, Linux for instance, you can look at the source code of the login process, and it has the backdoor password in it. So it's a bit obvious. So what do you do then? Because you still want to backdoor the login process. Well, you can then backdoor the compiler. So that if you compile the clean source code of the login process, it will produce a login binary that has your backdoor in it. That's all fine and good, but then somebody will go and look at the source code of the compiler. And then you will find a backdoor that, compiles the login and includes the backdoor. So what do you do then? Well, you compile a special version of the compiler that when it compiles the clean version of the source code of the compiler, it will produce a compiler that when it compiles the clean source code of the login process, it will produce a version of the login process that's backdoored. Now, again, thanks to one of my team members who actually from Hacker News managed to dig this out, I did remember vaguely recollection that I had heard a discussion where Ken Thompson said that, yeah, this was a hypothetical paper, and then in '95, roughly, he went onto the same systems and tried to log in, and the password still worked. So apparently he actually tried this out on one of their systems, and all that time it had still been working. It's a bit internet lore, but I had to dig quite deep in my memories because that post was from '95. I do recommend reading this particular piece of paper because it's so relevant today when you're downloading large language models from somewhere, or you're perhaps downloading Python code to run it in a very trusted mode in your editor or whatever. We've seen lots of backdoors of this nature over the time, more and more actually. There's so much open source abandonware out there, and the tree of dependencies that you have in your code to whatever is a real problem. So this fundamental thinking about what do you trust in your software development process becomes incredibly important. But yeah, I must admit there might have been one or two good papers on security written after this as well. The thing that for some reason I didn't put in here is, of course, Smashing the Stack for Fun and Profit by Aleph 1 in one of the early FRAC magazines. That one probably should be in the history books by now. All right, so why is this so hard? That's a question I ask myself. What's the point of coming up here and talking to you guys from something for 20 years ago? And as you saw, nothing has changed in 20 years. No, that's not quite true. One thing is that we have lots of legacy. And the legacy systems are such that most people the actual organization that have to run them. They don't necessarily know how they work. And I thought about picking, like, I picked an IE 20 years ago. And I thought, should I pick on like the firewall and VPN vendors now? But it was such a hard job pulling together all the vulnerabilities they've had over the last 2 years that I thought I'm not going to do that much work if I already had the slides made for me. But it is a real problem. The legacy code is very hard to change and fix. And then again, when did you actually get to start something new? Hands up those who actually started a new piece of software recently. Like completely from scratch. 1, 2, a few handfuls. So most of you end up working on legacy systems, working with old code. But those of you who did something new, how did that turn out? Right? You're usually under time pressure. You might have a product owner, somebody else, a customer that says that, actually, we would have liked to have that last month. Can we have it now? So you come up with something that's called a minimum viable product, right? MVP. From a security perspective, I question how viable that is. You know, software becomes good after it has been rewritten twice. But there's going to be some poor bastard out there that's going to be running your first version of the software. So where do we stand today? That's a really interesting question. I got a question from one of our VPs. It was a really good question. He asked me, how do I prioritize these security risks? Like, we have risk management processes. We can think about things that we know that are broken. And by the way, I'm not going to be able to answer this question, okay? This is the question you need to start asking yourself, right? Because it's unique for each software, for each situation. But the question becomes, how do I prioritize these risks? The number of security risks, the things that potentially could go wrong. Once you start producing that list, you might end up in a situation like, how many of you have seen that Excel? The risk Excel. The one with 300 rows of risks. Hands up. Yeah. You've seen the Excel. It's very effective, isn't it? So, the reason is here. For any particular organization, every context you have, it's about spending money. The new stuff will get more money because in the future, hopefully, it will produce benefit, value, and perhaps even revenue and more money. But the old stuff is much harder. And for any particular context, you will only have a limited amount of time and work time to actually work on improving security. You can't go with the assumption that now we have our 300 rows of Excel of risks or vulnerabilities, and let's fix them. Actually, my claim is you shouldn't be fixing risks, but we'll come back to that in a few moments. So, but where do we stand today? Like, walking forwards, and again, I've been talking as though I believe in the stuff I said 20 years ago, and I actually do. Most of this is pretty good advice still. But what can you do today? It's not as bleak. Like, this is not one of those end-of-the-world talks, I'm afraid. You can code in a safe language, and like C, C++, forget about it. Take a safe language and use a robust framework. By now, you have eliminated a large part of the trivial security vulnerabilities on the OWASP top 10. 2 steps. That's not that hard. 20 years ago, we didn't have those safe languages, and the framework didn't exist. So a lot of the things we have learned over the last 20 years has actually gone into our engineering frameworks. I think that's pretty brilliant. And actually, you can do automated vulnerability checking. There are so many vendors, so many technologies. You can put the vulnerability checks in your dependency tree to actually run. And you can get fairly reliable outcomes. Like some of the vendors say that they can actually merge the changes into your source code if you have dependencies in your source code. And they will tell you, based on their experience, how reliable that fix is. Right? So how likely is it to actually break your code? You can build a pull-based CI/CD pipeline to integrate this. So once your tooling, your security tooling, has proposed or perhaps automatically made a merge request, somebody has inspected it, approved it. Your production system, nobody needs to have access to your production system. Your production system will notice that there's new software available. It will actually pull it from your repositories and promote it, perhaps, according to your policy, to just a small amount of users to test it out first. Like 20 years ago, this was heavy magic. Nobody was doing this. Nowadays, the frameworks again exist to do this. Argo CD, whatever. Really cool things. And then, what do? You deploy unprivileged code in immutable containers. The containers is preferably ephemeral as well. So you put in a small unit. Well, it doesn't actually need to be that small, but it's well understood, it's self-contained, it's immutable. So if an attacker were to actually get write privileges, you can't write anywhere. And the containers are made in a way that they're throwaway. I can't tell you the context, but a colleague of mine at one point described a situation where the way to get some attackers to stop is to actually keep throwing away the systems. Now, with containers, you can actually keep doing this all the way. So even if an attacker is able to compromise a container, you can think about like how many minutes do they get before the container is killed. So you have tools at your disposal that are actually bloody close to magic. And of course, well, except if you use Enter ID, based on the talk earlier today, Nestori always breaks my thought patterns. I was thinking literally about the just-in-time authorization, and then you steal the token, and I thought about the token stuff a bit more, and I realized that all of those tokens that we have today, they're just passwords that have taken too many growth hormones. You can still steal it, and you give it to the other side, and the other side is, yeah, okay, good, I'll let you do that. Right? It's a bit like the speaker token that Nestor is talking about. Yeah, with this one I get the backstage. So, I don't know. When I wrote my master's thesis in 1996, there was already a better way of doing this part. So, perhaps that's not the best part. But anyway, do use just-in-time authorization and use short-lived secrets. Don't build those 3-year or never-changing passwords. You can actually build all of this in one single architecture. So that's it. We are in a much better position now than 20 years ago. So know your threat model. Focus on any code that runs with too high privileges. Again, the attackers might be interested in the low privilege stuff, but to be honest, not really. So if you need to start somewhere, start on stuff that runs with too many privileges. Or the too broad privileges. You know, the piece of code that over the years everybody has added everything to, and now it's a big mess. So you need to know the things you want to fix in your architecture. That's the answer to the question, how do I know how to prioritize these risks? You shouldn't be prioritizing risks. You should be prioritizing the most effective fixes that you have in your architecture. And also you need to know why. Because the same guy that asked, how do I prioritize these risks, will also be coming with your budget and your time to actually implement this. So think about this when you come out from here. Do you know your list of things that you want fixed and why? And if not, you probably should go back to the drawing board. So, I think we're in a much better position now than 20 years ago. It means that the next time someone says, nah, we don't have the time, we don't have the money, we can't make this secure, you should just disobey. Thank you.